So now we are calculating short circuit current of induction motor. So for calculating this short circuit current, we need to calculate first leakage reactance. Whatever the leakage reactance we have in this machine, we should calculate it. So there is some empirical formula for us for calculating leakage reactance of stator. For example, the formula is like this: 4 pi into 10 power minus 7. So 4 pi into 10 power minus 7, we have different parameters in this. All parameters we I just mentioned in the right hand side. So let's calculate it. So h1 by 3 into ws plus similarly h2 by ws and 2h3 by ws plus we. Similarly h4 by we, otherwise we can say w naught. So this is the formula, basic formula we have for this job. So here let's calculate all the dependent parameters. So here whatever you are observing here, that is a stator slot and a rotor slot and in between air gap of 1 mm we just mentioned in the figure. So here h1 for this machine comes to be 41.5 and h2 comes to be 4.75. Similarly h3 is a 3 and h4 is 1 and ws that is the slot width, that is a 9 mm, and similarly the slot opening we will say e exit, otherwise that is of 3.0 mm. So let's calculate lambda ss equal to 4 pi into 10 power minus 7. So 41.5 by 3 into 9 plus I am just substituting all the values into the formula so that we can get the desired value. 2 into 2 by 9 plus 3, here 1 by 3. So the coefficient we will get is 36.4 into 10 power minus 7. Similarly this is for stator slots, this is for stator slots. Similarly for rotor slots also we can calculate it. So let's write parameters for rotor, that is 29, h2 equal to 3.2, h3 equal to 3 and h4 equal to 1 and ws we that equal to 5 and wc equal to 2, this is the slot actually. So similarly for lambda sr for rotor we can calculate like by using same formula, 4 pi into 10 power minus 7. So here you have 29 by 3 into 5. Similarly you have some other stuff also like 3.2 by 5 plus 2 into 3 by 5 plus 2 and 1 by 2. So with this we will get value of 49 into 10 power minus 7. So let's refer this rotor value to the other side of from to the primary side, otherwise stator side. So we will get this value as 4 pi into 10 power minus 7 into 0.96 whole square divided by 0.958. this is the coefficients, 90 by 120. So 37 into 10 power minus 7 value we will get it. So we just converted to the other side. So finally if you refer to the stator side, what is the permeance value? 36.4 into 10 power minus 7, that is the stator alone value plus the calculated value from the rotor side, that is 10 power minus 7. So together will contribute for 73.4 into 10 power minus 7 value. So Now slot leakage reactance, let's calculate. This is the slot leakage reactance. So that is nothing but small xs. So let's calculate it. 8 pi f turns per phase into, you have length, entire length, and you have lambda s, that is the leakage, and you have P into Qs. This is the basic formula. In other sessions I will try to explain how we got this formula and how to derive this. I will explain it in the next sessions. For time being, let's just use this formula. So you have 50 heads and you have 360 turns in the stator, and you have a length of 0.250, and so let's substitute the remaining parameters. 73.4 into 10 power minus 7 divided by 10 poles you have, and number of slots per pole per phase is 3 for this case. So we will get 9.54 ohms. This is a normal slot leakage reactance value. Similarly, let's calculate for overhang. Whatever overhang you have at the terminations, let's calculate for that. So Ks equal to 1 for full pitch coils, because we took full pitch only, so that's why we are considering a value of 1. So like that we can calculate L naught into lambda, that is nothing but 4 pi into 10 power minus 7 into 1 into 0.204 whole square by pi into 22.7 into 10 power minus 3. So this value comes to be 7.34 into 10 power minus 7. So the overhang reactance, let's calculate overhang leakage reactance. So we have some basic formula for that, that is nothing but x naught, we will say 8 pi into 50 into similar way 360 square into 7.34, here 7.34 into 10 power minus 7 by 10 into 3, we will get this value as 3.96 ohm. So 3.96 ohm. So magnetizing reactance, whatever magnetizing reactance is there, let's calculate that. Magnetizing reactance, we will say X, magnetizing reactance Xm. So this Xm is nothing but E by Im. So E we already know that 1910 divided by, we now calculated a value of 9.05. So it comes to be 211 ohms. Now zigzag leakage reactance, that is another figure we have to calculate. Zigzag leakage reactance. So with this zigzag leakage reactance, small xz, that is nothing but 5 by 6 into xm by, we have some basic formula, so let's use this formula so that we can calculate it, all the parameters. So 5 by 6 into xm we calculated like 211, and ms, that is the number of phases, 3 square, and 1 by 3 square plus 1 by 4 square, that is number of slots per pole per phase. So this value comes to be 3.4 ohms. So let's calculate harmonic leakage reactance. So we have there is some harmonics also. So let's calculate harmonic leakage reactance. That's value is nothing but xh, we will say, that is xm into, so khs, similarly khs, that is the factor we will use. So for this case 211 is the xm value, 21.6 plus 21.6, so minus 10 power minus 4. So you will get value of 0.91 ohms. 0.91 ohms. So total leakage reactance of machine. Total leakage reactance of machine. So we refer to the stator side. So refer to stator side. XS is nothing but that is 9.54 gap value and 3.96 and 3.4 and 0.91. So with this total value comes to be 17.81 ohms. So let's calculate resistance also. Total resistance of machine. Total resistance of machine referred to stator side. Stator side, we already calculated this value. Refer to stator side, we will say RS, capital RS, that is nothing but 3.56 ohms. So we calculated it like RS plus RR dash, that is nothing but 1.46 plus 2.1. This is the way we calculated this RS. So total impedance, whatever impedance we have, total impedance is nothing but ZS. So that ZS is nothing but reactance square plus resistance square. Resistance is 3.56 whole square. So we will get this value as 18.15 ohm. So let's calculate the short circuit reactance. So short circuit current ISC, we will say ISC. So let's short circuit current, otherwise some will say blocked rotor. So let's calculate this value. We know 1910 is the voltage and the impedance 18.15. So with this we got this value as 105 ampere. And the short circuit power factor PF is nothing but cos pi SC. So that value is nothing but the ratio of R by Z. So 18.15. So that will give 0.196. This is a little bit improved power factor when compared to no load condition. Similarly, we can calculate the angle phi SC. So that phi SC will comes like 78.42. So this is about this short circuit current, guys. So now let's calculate losses and efficiency. So we have losses and efficiency, many losses in the machine. Finally, let's calculate how efficient the machine is. So we have stator copper loss and copper loss of 2740 watts. Similarly, we have rotor also. For rotor also you have copper loss 2860 watts, and we have iron loss. Iron loss is the total iron loss. We have 3760 watts, and friction and windage loss generally we took like 1% of total output power. So this is 1100 watts. So with this, let's summate everything. Total copper loss, total losses at full load. At full load, let's calculate total losses. That will summates to, if you calculate everything, 10460 watts. We know that output at full load is nothing but 110 kilowatt means 110,333. So input at full load, that is nothing but 110 kilowatt plus we should add this 10460 extra. This we should add this 10460 extra. So that will comes like 120,460 watts. So the efficiency, so finally efficiency at full load comes to be 110 output by input, so 120,460, that value comes like 91.3%. So 91.3%. So let's less half percent from it, so you will get 90.8%. So let's calculate slip value also. Slip, whatever the slip at full load, slip is nothing but percentage speed at the percentage difference in speeds. So that is the slip value. So rotor losses 2860, rotor copper losses divided by total 110, total losses, total rotor losses, so 1100 watts. So with this the slip value comes to be 2.5%. 2.5%. Yeah. So this is about this, guys. I hope the video is informative for you. So circuit diagrams and all we will calculate, we will discuss in later sessions. Thank you.